Okay, lesson 5.2 right here. This is the application of exponential functions. So we're going to take what we learned in lesson 5.1 and use them to solve real life problems, usually involving population or science related problems you'll find. So they tell us that the population of a city is modeled by this formula, 490, okay, this following formula, where T stands for years and 493,000 starts as the initial value at a certain point in time. And they want to know what the population is going to be in 7 years using this model. So all we have to do is type that into our calculator right there, 493,000 times E, and you just replace the T with the 7, and you get 446,997, okay? So that's going to be, if you work that out, that should be 446,998. You actually round up to the nearest whole person in that case. Follow the directions that are on Hawks, but I think that's what it is. Now, this is a cost function, a cost of production, okay? So let's say a car. So the cost to produce a certain car at a certain time is equal to the cost it costs now to produce that car or that item, times 1 plus R, that's the rate of depreciation, okay? Or excuse me, not rate of depreciation, in this case, inflation, sorry. It's increasing the costs these days. So it's the cost, that's the cost that's increasing, and to the number of years is the power. So what they want to know is, what is this car going to cost to make in 15 years, assuming that it's increasing by a rate of 1.5% yearly every 15 years, for 15 years. So right now they want to know the cost of to make a $30,000 car, which it costs now. What's that going to cost in the years ahead? So what we do here is we put in 0.015 as a decimal here because they gave that to us. So we're going to have 30,000 times 1.015, and we raise that to the 15th power, okay? And we calculate that on our calculator right there, okay? 1.015 to the 15th power, we get 1.25, and then we multiply that times 30,000, and we get $37,506.92. So that's $37,506.92. And that's what's going to cost to make that car 15 years from now, if the cost to make it increases by 1.5% every year. That's what that's saying. All right. Number 3, they tell you that you have a depreciation of a certain item, and right now it costs $652 in order to be able to make. And it's depreciating by 20% every year, and they want to know in 4 years what's it going to be, what's the value of that item going to be. Think about this like a car, sort of. I mean, this is lower money, but it's like an item that's depreciating over time, where it's losing 20% of its value every year. So they want to know in 4 years, how much is that $652 item going to be? Well, what we can do here is we take 1 minus 0.2, which will be 0.8. It's going to be 0.8, right? Raised to that 4th power, because it's 4 years, and that gives us 0.4096. And then we multiply that times the original amount, which is 652, which originally what its value is, and that'll give us $267.06 if you round off. Okay, there you go. 6 cents, not the 6th sense. All right, that's a movie. All right, now number 4, they start off with 108 rabbits, and that's the original population. They're saying that the population of these rabbits grow exponentially. If you know about rabbits, you know that they increase their population very quickly. And they tell us that there's 972 rabbits 2 years later. Okay? So what we want to know is, how many rabbits will there be in 2 years and 9 months? Okay, that's what they're asking us. So, well, what they're telling us is that now if you look at the slides, you might encounter a formula that might be helpful here, but just what do? You use the information that we know. We know that we have 972 rabbits, okay, at 2 years after, okay? So the population at a certain time is equal to the amount that you have originally, 108 rabbits, okay? And then times A's that's our base. That's the number, that is our base. We're trying to find out how many times the rabbits multiply every year, all right? So if we divide this out by 108, we're going to get 9. So we know that 9 is going to equal to A, our base, times some power of t. Now we know its power of t is 2 because they told us 2 years. They told us that 2 years we have 972 rabbits. So we take our basic formula, which is P of t, a population at a certain time, is equal to our original population times A of t. And that's the formula that you'll see inside the slide. So if 9 is equal to A to the t. So we're going to try to change these to match them up, right? So we could say that 9 is equal to, we know it's squared, so we know 9 is equal to A squared because t is 2, right, for 2 years. So then we say 9 is equal to what? 3 squared. So we could see that A is equal to 3. And since A is equal to 3, we could figure out the rest of what they want to know. So that's the part A. The part B is they want to know is how many rabbits will we have in 2 years and 9 months? Well, if we want to figure that out, we could figure that out by saying that we want to know that P of 2.75, well, that's going to equal the original amount, 108 rabbits, right, times our base, which is 3, okay, our base, to the what's going to be 2.75, okay? So we put that in our calculator, and we figure out what that is. So put that in our calculator, I don't know if you can see that. So you see we've got 3 to the 2.75, and that gives us 20.51, okay? So we're going to have 20.51. That's our multiplier, actually. It's not how many rabbits we have. And we have to multiply that times 108. So we have to multiply that times 108, okay? So we get 20.51, we multiply that times 108, and we get a huge number right there. And you see what we get? We get 2215.68. Okay, so that'd be 2215.68. That'd be the number of rabbits approximately. So you round up to the next number of rabbits. Well, I think the question asks you to round to the 100th, even though it's like not a whole number of rabbits. All right, now we're on to number 5. All right, number 5. The person wants to make $700 interest in 3.8 years with a semi-annual interest rate, and they have $14,000 to make that interest from. So if you check, you'll see there's a formula in the slides that show us that means that you want to have $14,700. $14,700. We want to have that. Okay, let me write that out. Bigger color there. So we want $14,700. That's what we want, a certain amount of time. That's the amount at a certain amount of time is equal to 14,000, which is what we start with, okay? Times 1 plus my rate over 2, because it's semi-annual. That means it's done twice a year, okay? Now, careful now, it's going to be 3.8 times 2, because it's half a year's, right? So it's 7.6. So therefore, it's going to be 14,700 is equal to 14,000 times 1 plus r over 2 to the 3.8, okay? Then we're going to divide both sides there. Divide both sides by 14,000. And we get, what's that, 0.05. So we get 0.05 is equal to 1 plus r over 2 to the 7.6, all right? 7.6. So what we need to do to get that r there is we need to raise that both sides to the 1 over 7.6 power, okay? And if we do that, we're going to get 0.05 to the 1 over 7.6 power, okay? And that's equal to 1 plus r over 2. And we just need to subtract 1, okay? So we have 0.05 to the 1 over 7.6, subtract 1 equals r over 2. Then r is going to equal to 2 times that. So it's going to be 2 times 0.05 to the 1 over 7.6 power minus 1 in parentheses, okay? and that comes out to 1.29%. Yeah, 1.29% after you multiply by 2. Now, number 6 is really a little bit of a reading problem. If you misread it and miswrite it down, you can drive yourself crazy going in circles, and I don't want that to happen to you. They tell you the time, we want to know the amount of time it takes for the deer population to quadruple, or to be 4 times as much. And they tell us that the population of the deer can be modeled by this equation. Population at a certain time equals original amount to a certain power. Well, if we do this, oh, actually, I think it was 4 to the 3t. So the equation is P of t is equal to 236 times 4t to the 3t. Okay? That's the formula it's modeled by. They told us that. So therefore, what does that mean? That means that my initial amount is 236, and I'm quadrupling, so my base is a 4. So therefore, I'm going to have 4 times as many at a certain time. So I originally start with 236. So if I multiply that by 4, I'll get some number. So I'll get 4 times whatever 236 is. Doesn't really matter because I'm going to divide it out in a second. Equals 236 times 4 to the t over 3. So when I divide out 236 on both sides, I know I'm going to have 4 equals this. So okay, I don't want to skip that step for you. So you have 4 is equal to 4 to the t over 3. So therefore, t is equal to 3. Now, the last part of that problem was they want to know when is there 3,776 deer. When is that going to be true? Well, we know from the equation that P of t is equal to P0, or actually in this case, 236 deer to start with times 4 to the t over 3. That's what we know. So basically our P of t is 3776, okay, equals 236 times 4 to the t over 3. So we have to divide out both sides by 236. And if we do that, we're going to get 16 is equal to 4 to the t over 3. And we need to solve for t. We want to know when is this population going to get that many deer. So we write this and line up our bases like we did in lesson 5.1. We want to get the common base or common exponent so we can equate them. So we have 2 is equal to t over 3. So therefore we have t is equal to 6. So 6 years, the population of deer will be 3,776. All right, how much we make from selling a product to revenue is equal to how many we sell times the price we sell it for. And we're given a formula for the price of a product is equal to 41 times 4 to the negative x over 6. That's a negative. And we're asked if 6 are sold, what's the revenue? Okay, what's the revenue of 6 sold? So if we're going to do that, we're going to have 6 times 41 times 4 to the negative 1. And if you calculate on the calculator, you should get $61.50, round to the nearest cent. All right, well, in this problem, number 8, we have $5,600 to invest, and we could either choose an account that gives us 2.6% but gives us daily interest versus an account that gives us 5.4% but only gives us interest monthly. So what we need to do there is take the 5,600 times 1 plus the rate, which is 0.026. You have to enter that as a decimal, over 365 because it's 365 days in a year. Let's just do 1 year just to compare. All right. Now they didn't say how much time, so we're just going to take 1 year. And this one's going to be 5,600 times 1 plus, and that'd be what? 0.054 over 12 raised to the 12th power, just because again we're just assuming 1 year. Now if we do that, this one's going to give us 57.47, and this one's going to give us 59.10. So clearly account number 2, the one that gives us monthly interest at 5.4, is going to be greater. Now they ask us, well, if we put that money into account 2 for 1.8 years, how much would we have? Well, we'd start out with 5,600. We multiply times 1 plus 0.054, and it's monthly accrued interest, so we divide by 12. Now it's going to be 1.8 years. We have to multiply times 12 because there's 12 times that we're getting interest, 12 periods. So if we multiply that all out, we should get $6,100 and $670.31. So remember, it's not, we don't just add that to get 20 months. It's 1.8 years times 12, and that's how much we get. 6170.31.